Hi, my name's Brian. In this video, we're going to be looking at the fourth computing project, which is Planar Beam. We'll be looking at the pseudocode for the CP. The pseudocode is based off of the axial bar CP, but we're going to go ahead and take a look at how things have changed from the axial bar to the planar beam. So the first thing we're going to do is initialize the physical inputs, such as EI, the load function type. We can go ahead and use the load function from the first computing project, the length of the bar, as well as the amplitude of the load function. So here we have the governing equations for planar beams, and we're going to have to integrate the right-hand side of the equation, so that's I0, I1, I2, and I3. You can use the same code that you developed from the first computing project, and we're just going to be changing some things to go from an axial bar to a planar beam. Here we have the governing equations in matrix form. We'll need to compute this matrix in order to solve the system. Here F is the solution array and Z is the right-hand side of the system of equations. Let's go ahead and look at the boundary conditions and how they are used in this computing project. For example, we'll look at fixed conditions. There's no rotation or displacement at either end, but there is shear and moment. We can go ahead and reduce the system of equations by eliminating these columns and rows. Now we have the reduced matrix C and reduced solution array S. Now we have 4 equations and 4 unknowns which we can solve. After solving, we have the S array, which has the unknowns. However, for each set of boundary conditions, these unknowns will be different, so we want to fill in the unknowns into F based on the boundary conditions array. Anywhere we said we had an unknown, we can fill in from S. Note that you'll have to initialize F as an 8x1 of zeros for the planar beam problem. We can do this with one line of MATLAB code, shown on the left. This line says that we will replace the indices of F where there were unknown boundary conditions with the values we found from S. Now we have the full system solution array, which we can use to initialize generalized trapezoidal rule. Generalized trapezoidal rule will allow us to find all of the values of shear, moment, rotation, and displacement from 0 to L and then plot them. That's all for this video. Thanks for watching.